Hello, this is Aaron from ToolChef. In this video I'm going to show you how the navigation component works. I have a simple setup with a real mannequin that converts to an Atoms asset that's using a simple state machine with a locomotion node that's using a blend space asset. The blend space asset is using the idle and the work clip of the mannequin. The velocity used by the blend space is controlled by the target linear velocity metadata that at the moment is set to 300. If I press play, now you see the agent just works straight, doesn't do anything else. So let's add the navigation behavior component. Obviously, you need to have a valid navigation mesh in your lever to be able to use the navigation behavior. So the navigation behavior queries the navigation mesh and use the nav path that it gets from the nav mesh to drive the agent to a specific target position. Let's have a look to the parameter, the target navigation behavior. So we have different target modes. You have target position, random point, point sequence, target actor, and target actor sequence. So let's start from the target position. The target position basically is the simplest mode. Basically use a absolute word position that you provide on the target position property, and the navigation component use that position to get a nav path. So for example, now he's trying to reach the 000 that is somewhere there, but for example I have this target pointer that is there. Let's copy the position. Oops, sorry, not here, and here. That's on target position. I can turn on the debug mode to see the path the agent will follow. And now probably one thing that we need to change immediately is the max turn angle. The max turn angle is the maximum angle degrees per second that the agent can use to turn to follow the path on the nav mesh. At the moment using 10 degrees per second, it's quite low. So let's increase this one to 200. So let's press play. Let's have a look at the simulation. So now let's see. You see that the agent basically reached the target and he continues to try to reach his target because the navigation component doesn't do any other action in this mode. So in the target position, you can use an absolute position here. Obviously, you can override this position per agent. Or if you have a metadata containing a position, you can set the metadata name here. So for example, if I set add a new metadata and call target, for example, you can go here and use the target. Actually, I need to change the type to vector, and for example, let's move this one here. Let's get the position, and then I have my add metadata there and set the new position here. Now you see basically it's reading the position from the metadata and not from the component properties here. Let's have a look at some other parameters that you can use with this mode. Another one is the trigger metadata. The trigger metadata basically is a metadata that the module can set to a specific value that you provide here when the agent reaches its target. So for example, if we want make the agent stop when it reaches this target, we can control and modify the target linear velocity. So if I go on the navigation behavior, I choose to set the target linear velocity to 0 with a fall-off time of 1 second. So it will interpolate the target linear velocity to 0 in 1 second. So if I press play now, let's have a look. Yeah, you see, try to slow down, but there is something that is not working correctly. Now let's fix it. So one parameter that you want to change is the target radius. The target radius is the radius used to know and check if an agent has reached its target. And we can also check the distance, do this check in 2 dimensions instead of 3 dimensions. So if I turn on the check there, then the agent should have enough time to stop without go outside the target radius, because otherwise it go outside and it try to reach the target again. Okay, so let's have a look to another mode. Actually, yes. Let me explain the option for the navpath query. So the first one, is the compute path every tick. This one means that the agent compute a new path every tick. This can be quite expensive if you have a lot of agents. So if you have a lot of agents, probably the best way is to turn off this option. Probably you can turn on the optimized path visibility that try to optimize the path, because basically when agents query the nav path, you return the corridor, that is the list of the polygons I need to follow, and then at every tick it automatically compute the straight path of the straight path using the first set of polygons up to the first basically corner. That is quite, in this way it's quite fast compared to compute a full path every time. You can also choose to allow the partial path query if the path is quite long. You can turn on this option. Also, there is project properties they can use if you have really long navigation path. If you go on plugins, Atoms Crowd, by default Atoms can store up to 500 polygons to basically to compute the full path. If you have really long path, you see the agent is not able to reach his target, you can try to increase the corridor length. And here, yeah, the partial path query. Actually, if you turn on the compute path every tick, so if you need to compute the path every tick, here there is another attribute that you can use to basically take under control the time spent by the nav query. For example, in this case, you can choose to let only 50 agents per tick to query a new path. In this way, if you have 1000 agents and you need to compute a new path at every tick, but you see that compute for all 1000 agents is too slow, you can clamp the maximum number of agents that can compute the path every tick. But for now, we don't need this. Then we have the path wall offset. So let me move this one here, for example, and let me copy the position, and on the navigation let's update it's the right one, copy, yeah, sorry, actually need to remove the target metadata and copy this one, navigation behavior, and plus the new. Okay, so we have the new path there. Actually, the path is really close to the border, the nav mesh. So what the basically the path wall offset does, it try to push basically the path away from the corner and from the wall of the nav mesh. So if I push, I don't know, 50, you see that basically push it away a bit there. And here, let's have a look. Okay, so let's have a look to the other modes. Okay. So let's have a look to the random point. So with the random point, basically the agent try to reach a random point, random position on the nav mesh. So if I press play there, you see basically just reach a random position there, and then stop, because it's still setting the target linear velocity. But for the random position, we have this option, define new target point or reach. This option basically it makes the agent choose another random point as soon as he reaches the current random point. Okay. Now let's have a look to the other mode, point sequence. So the point sequence basically the agent reach basically use a sequence of points. So for example, if I take this one here, that one, and that one. So if I now copy this one, copy this one, and let's add a new index, copy this one, and pass this one. So if I press play, you see the agent just follow a specific sequence. If we want, we can turn off the loop of the target sequence. So if I can turn off this one, I made the agent reach that, reach the second, and then finally stop the last sequence point. If you want, you can override the sequence index. So this one basically instead to start from 0, 1, and 2, you actually manually set the sequence index. So if I set to 1, you see that immediately go there, go 2, 1. This way you can animate this one to like animate the target point here. You can actually, the sequence index can work with this other option. Basically, as soon as the agents reach the sequence index, even if the agent go outside the target radius, then it completely ignore the other sequence if you have this option active. Let's have a look to the other two options. So the target actor is similar to the target position, but has a couple of more interesting options that you can use. Also with the target actor, you need to provide current target actor. That, for example, would be my target pointer. So if I press play like this, just reach the target. We have the same thing with the target actor sequence. Here you can provide a sequence of different actor. I actually set the sequence index to -1, so it's not overriding anymore. And then it's exactly the same of the sequence point, but instead now it takes the position from the actor. Now let's go back to the target actor. So the target actor has a really useful feature that you can use for formations. So let's create some more agents. Now with the target actor mode, it's possible to use the target formation component you can attach to an actor. We can basically extract a formation from a live agent group. What we can do, just select the agent group, go to agent group action, create a target formation actor. It generates this new target point, this new target point with this target formation actor. If I increase here, you see basically there is an arrow for each agent, and the arrows has the direction of the agents. Now if I go here and place, for example, my formation here, and let's delete the other points. And now if I go on my navigation, let's put the target actor, and now my target point. Now you see basically every agent has its own target. Press play. Basically the agents reach the target. If I select the agent group and then rotate them, for example, and if I press play, now the formation is not only it's not have only position but also direction information, so the agent can assume a specific direction when it reaches its target. You see the arrows here, so it means that the agent, when it reaches target, and then it just try to assume this direction. So if you want to tweak this formation, we can do manually if you want. So if you go on the target formation, on the advanced, there are all the agent information data. So here, for example, for the agent 0, I can change the direction to, I don't know, actually, something like this. Yeah, you see here, now I'm setting on that direction. You see, now it's in a different direction. Now, obviously, doing this manually is not so simple. So what we can do is use another agent group with the layout tool. So if I go to the agent group, actually, sorry, first let's go to the here where I have the agent type. So I need to select an agent type in the content browser. Now if I select my target and do a right click, formation actor, create an agent group. Now basically it generated this agent group with a points layout. like here, and then basically, so sorry, not this one, yeah, this one. Now I can use the layout tool to modify the layout. Also the mode. Can, for example, take this guy, rotate them, and I don't know, takes the other guy here, move them a bit there, something like that. Then I can exit my agent layout tool. I can actually close this one. Now I can copy this formation to my formation component. So let's select the agent group, and then my target point, right click, formation, copy layout from agent group. And now my layout, my formation actor has the new layout. You can do the opposite, so you can copy the position direction data from formation actor to the agent group and so on. So in this way it's more easy to tweak your formation. So right, you can delete that agent group that I don't need anymore. Sorry, let me exit from there. So let me refresh here. So you see the new path. So if I press play, I have the new formation there. Actually, now you see the formation. Actually, if you check the target formation component, you have the agent here. You have some parameter, like you can offset the rotation, for example, like this. Or you can basically, you can use the data in workspace instead to local space, or you can use the layouts, a layout asset. A layout asset basically contain the same agent's data here, but instead basically using this data on a live actor, use data stored as an asset. So if I go in the agent group, for example, right click, create an agent layout asset, and I save, I don't know, the content. Let's change the name. Save. Now I have my layout asset here with basically the same data. And here with some global transformation data. Then to use that, I can just use the target formation and assign my layout. Now you see, I have the new layout. Actually now is using the layout in local space. Which one I can turn workspace to get basically the workspace there. So you can use the target formation component on any actor. In this way you can basically provide your custom formation. The same thing go for the target sequence. So if you have multiple actor with these formation components, the agent basically basically use the sequence but using the formation information. So that's it. Thank you for watching. See you in the next video.